We've all been there, just staring down this mountain of information.
No, absolutely.
You need to get your head around some complex topic, maybe for class, maybe for work, and you're just drowning in articles, research papers, endless online chatter.
Information overload is real.
Totally. You just want the keys, the surprising facts, that kind of aha moment that just cuts through all the noise.
Exactly. The core insights.
Today, that's exactly what we're aiming for. We're diving deep into something that's everywhere, and it's profoundly reshaping our world. Generative AI. And look, this isn't just about futuristic robots or anything. It's about understanding a really fundamental shift in technology, something that impacts everyone, especially, I think, those of you navigating this rapidly changing academic world and the professional one, too. It's a tool, it's a phenomenon, it's definitely a challenge, all rolled into one package.
It truly is. And what's so fascinating, I think, is just how quickly AI has gone from being this niche, almost sci-fi concept to an everyday tool. And this new wave, generative AI, it's really front and center now. So our mission today really is to demystify it for you, give you the essential knowledge so you feel confident, you feel informed, not overwhelmed.
Cut through the hype.
Exactly. Cut through the hype, get you that solid foundation.
So what can you expect from this deep dive then? We're going on a bit of a journey. We'll start by unpacking what AI actually is, the basics. Then we'll sort of pull back the curtain on how this newer generative AI, how it works its magic.
The mechanic.
Exactly. We'll explore some of the incredible applications. We're talking high fashion, deep sea navigation, all sorts of things.
Some really cool examples there.
And just as crucially, maybe more crucially, we'll grapple with the critical risks, the ethical questions, the responsible ways to engage with this powerful tech.
That's vital.
So this deep dive, it's really tailored to help you, our curious listener, our learner, grasp these fundamentals thoroughly, confidently, so you're ready to adapt and hopefully thrive.
Okay, so let's start right at the beginning then. When we talk about AI, artificial intelligence, what are we actually talking about?
Yeah, good question. At its core, its most basic level, AI is software. Software that's designed to mimic or sometimes even improve on tasks that typically need human intelligence.
Okay.
Think of it as getting machines to do things that, until pretty recently, only our brains could really handle. Reasoning, learning, problem solving, that kind of stuff.
Got it. So machines doing smart things.
Essentially. And here's where it gets really interesting for most people.
Yeah.
You're almost certainly using AI every single day, probably without even thinking about it.
Okay, like what? Give me some examples.
All right, well, take Google search. When you type something in, it's not just randomly pulling up web pages.
There are AI algorithms working constantly behind the scenes. They rank the results, they personalize them for you, trying to show you what's most relevant.
Ah, okay. That makes sense.
Or think about your email spam filter, just diligently sifting through everything, blocking the junk.
Yeah, thankfully.
That's AI, classifying messages, making decisions, all without you lifting a finger.
Huh. Okay, I never really thought of that as AI.
Exactly. And even common things like spell check on your phone or a writing assistant like Grammarly.
Sure.
That uses AI to understand language, suggest corrections, help you communicate better. It's genuinely all around us, often just quietly humming away in the background, making our digital lives a bit smoother.
It's kind of invisible then, a lot of it.
A lot of it, yes. And that invisibility, that seamless integration, it's a really stark contrast to where AI was just, say, a few decades ago.
Oh, yeah. How so?
Well, we had this period, roughly the 1980s through the early 2000s, that people often call the AI winter.
AI winter.
Yeah, it was a time when basically enthusiasm for AI kind of dried up. And more importantly, the funding for research collapsed.
Why? What happened?
Well, a lot of the early, very grand promises about advanced intelligence, they just didn't materialize.
I'm overhyped.
Exactly. Overhyped and underdelivered. A series of ambitious projects failed, leading to pretty widespread skepticism. Back then, the goals for AI were much more specific, more narrow.
Like what?
Things like mastering a game like chess, Deep Blue beating Kasparov, or very rudimentary speech recognition. It was all about performing these predefined specific functions, not really about creating something totally new.
Okay, so doing tasks, not creating stuff.
Precisely. And that's the fundamental difference with generative AI. This marks a genuinely different kind of breakthrough. It moves beyond performing tasks to actively creating things.
Creating. Like what?
So instead of just recognizing a picture of a cat, which older AI could do, generative AI can actually generate an entirely new, completely realistic image of a cat, one that has never existed before.
Wow.
This whole wave of AI, it's about creating original content, text, images, music, code. And it does this using what we call large language models, or LLMs.
LLMs. Okay, we'll get into those.
We will, but a prime example, maybe the one most people first encountered, was ChatGPT 3.5.
Oh, yeah. Everyone was talking about that.
Exactly. Its launch really showcased these new capabilities, generating incredibly human-like text, summarizing complex stuff, even acting as a kind of personalized tutor. It demonstrated a level of creative output that just felt genuinely new and, frankly, transformative.
We could write essays, poems.
All sorts of things. And that ability, that power to generate something fresh, it's largely guided by you, the user.
Okay, how does that work?
Well, the secret sauce, you could say, lies in what we call prompts.
Prompts.
Think of it like this. You're the director, and the AI is your incredibly fast, incredibly talented, but very literal actor.
Huh. Okay, I like that analogy.
Your prompt is the script. You guide the AI by giving it specific questions, tasks, instructions. You might type in, write a short story about a detective in a futuristic city.
Okay.
Or maybe, summarize the scientific article in 5 bullet points. That's your prompt.
Got it. And what's really cool about this, what makes it so powerful, is that it's not just a one-shot deal.
Exactly. It's interactive. It's iterative.
Iterative.
Meaning you go back and forth. The AI gives you a response, its first draft, let's say, and then you can refine it. You give it follow-up prompts. You might say, make that detective story funnier and add a plot twist.
Or take those bullet points and make them sound more formal for a presentation.
Precisely. This back and forth lets you continually steer the AI's creativity. You nudge it, you guide it, until you get something closer to what you're actually looking for. It becomes a kind of collaboration.
A human-AI collaboration.
In a way, yes. Now, what's particularly striking about these new capabilities is just how fluent the outputs are, how convincing they sound.
Sometimes it's hard to tell it wasn't written by a person.
Whether it's an essay, a poem, a piece of computer code, generative AI can produce content that sounds remarkably human, authoritative even.
But there's a but, isn't there?
There is a very significant but. This fluency, this convincing tone, it comes with a critical early warning sign, something that's absolutely vital for any user, especially students, anyone relying on this for information, to understand.
So what is it?
This raises a really important question. If an AI can sound so confident, so authoritative, while being completely, utterly wrong, how do we tell the difference? How do we discern truth from fiction? This phenomenon, it has a name. We call it hallucination.
Hallucination. The AI is seeing things.
Sort of. It's when the AI basically fabricates information. It makes up names, events, data, sources, essentially inventing things out of thin air, but presenting them with absolute confidence.
Yeah, that sounds dangerous.
It can be extremely dangerous. There have been documented cases, for instance, where AI tools have invented fake legal cases, citing court rulings that simply don't exist. Imagine relying on that for legal advice.
Yikes. Yeah, that's bad.
That's a critical risk you absolutely need to be aware of, and it's not the only one.
What else?
Remember, generative AI learns from vast amounts of existing data, mostly scraped from the internet.
Right.
If that data contains biases, racial bias, gender bias, any kind of societal bias, or if it contains offensive content,
And the AI learns that too.
it can inadvertently perpetuate or even amplify those biases in its own outputs. It reflects the flaws in its training data.
Okay, so biased output is a risk.
Definitely. And then, of course, there's the potential for outright misuse. People intentionally using these tools to create harmful content, generate fake identities for scams, or produce incredibly realistic deepfakes.
Deepfakes. Those fake videos and audio clips.
Exactly. Impersonating real people, faking events. It makes it increasingly difficult to trust what we see and hear online. So understanding these early risks, hallucination, bias, potential misuse, it's paramount for anyone using these tools. You have to be critical.
Okay, so despite those really crucial risks, which we absolutely need to keep in mind, there's no denying this feels a transformative moment in technology, doesn't it?
Oh, absolutely. The hype is immense, but there's real substance behind it, too.
I mean, you hear major figures talking about it in huge terms. Bill Gates said it's as significant as the PC.
That's a big statement.
And Sundar Pichai, the CEO of Google, went even further, saying it's more profound than fire or electricity.
Wow. I mean, whether you agree with that level of comparison or not, it shows the perceived scale of this shift.
Right. And the key takeaway seems to be this leap, this jump from just retrieval to actual generation.
Exactly. Information retrieval is about finding existing data, like a search engine finding a web page. Creative generation is about making something new. It's not just pulling up an existing web page, it's writing the content for a brand new one from scratch.
That's a fundamental shift.
It is. And the excitement around it is palpable. But as you alluded to, it wasn't all smooth sailing. There were growing pains, controversies.
Especially around the launch of ChatGPT.
Definitely. Its public release particularly sparked a lot of debate. It was let loose, essentially, without the kind of extensive, rigorous oversight you might expect for such a powerful technology.
Which raised concerns.
Immediately. Significant concerns about AI safety, potential for widespread misinformation, misuse, all the risks we just talked about.
But it also kind of set the standard, didn't it?
It undeniably positioned OpenAI and ChatGPT as the face of AI innovation. It grabbed headlines, secured massive investment, particularly from Microsoft, which integrated the tech into its products.
Right, like Copilot.
Exactly. But that success also ignited this incredibly rapid, almost frantic competitive response across the whole tech industry.
Everyone else had to catch up.
Pretty much. Google rushed out Gemini. Meta released its open source Llama models. Amazon introduced Titan through AWS. This huge competitive rush, really born from ChatGPT's breakthrough moment, highlights both the immense perceived potential and maybe the urgent need for more responsible, careful development.
Okay, so let's pull back that curtain you mentioned earlier. How do these things actually work? These large language models, LLMs, how are they built? How are they trained?
Right. Let's get into the mechanics. It generally starts with what are called foundation models.
Foundation models, okay.
You can think of these as massive general-purpose AI brains. They're trained on truly enormous data sets to learn the underlying patterns of language.
Enormous how? What kind of data?
We're talking vast collections of text, primarily, think Wikipedia, countless news articles, millions of books, websites, conversations, even computer code. Huge swaths of the internet, basically. Through processing all this data, the model learns the intricate structure of language. Grammar, syntax, meaning, context, the relationships between words and concepts. It learns this across billions, sometimes trillions, of words or documents.
Okay, so it just reads everything.
In a manner of speaking, yes. But what really gives these models their sophistication are things called parameters.
Parameters, I've heard that term. What are they?
Think of parameters as like billions of tiny adjustable knobs or switches inside the AI's virtual brain.
Billions.
Billions, yes. Maybe even trillions in the latest models. Each parameter helps the model recognize a specific pattern or relationship in the data it learned from a nuance of grammar, a common phrase, a stylistic choice, a connection between ideas.
So more parameters means?
Generally, more parameters means the model can capture more complexity, more nuance. It leads to more sophisticated language understanding and generation. For example, GPT-3, which powered that initial ChatGPT excitement, famously had around 175 billion parameters.
175 billion, that's staggering.
It is, and newer models like GPT-4 have even more, though the exact numbers aren't always public. This immense scale requires equally immense computational power to train.
I bet.
We're talking about using thousands of specialized computer chips, GPUs, graphical processing units running constantly for weeks, sometimes months, just to train one of these foundation models.
Wow. So huge cost, huge energy use.
Absolutely. It's a staggering amount of data crunching, allowing the model to find incredibly subtle connections and patterns in language that humans would never consciously perceive.
Okay, so that's how they're built. Massive data, billions of parameters, tons of computing power. But how do they actually, use that knowledge to understand and generate text?
Right, the operational part. It's quite ingenious, actually. They primarily operate using something called token-based learning.
Tokens.
Yeah, tokens. When you give an LLM an input, like your prompt, it first breaks that input down into smaller pieces called tokens. A token can be a whole word, or sometimes just part of a word, like a prefix or suffix, or even just a single character or punctuation mark.
Okay, so it chomps up the text.
Exactly. And then it analyzes the relationships between these tokens. Its core fundamental function, what it's constantly trying to do, is to predict the next token in a sequence.
Predict the next token, like autocomplete on steroids.
That's actually a pretty good analogy, but way, way more sophisticated. Based on the vast patterns it learned during training, seeing which tokens tend to follow which other tokens, in billions of examples, it calculates the probability of what the next token should be.
Okay, so it's all about probability.
Fundamentally, yes. This prediction process allows for these remarkably context-aware responses. The AI doesn't just look at the last word. It considers the whole sequence of tokens in your prompt: the tone, the grammatical structure, the topic, even the implied meaning. And based on all that context, it predicts the most likely next token, then the next, then the next, generating sophisticated outputs like essays, summaries, answers to questions, code, whatever you ask for.
Sounds like it understands.
It sounds like it understands. That's the key distinction. If we use that real-world analogy again, it's like a hyper-fast reader with a perfect, massive memory. It can recall and synthesize information so rapidly and fluently that it mimics understanding incredibly well.
But it's not actually thinking.
Correct. It isn't truly conscious. It doesn't think or feel or understand in the human sense. It's a very complex probabilistic machine predicting the most likely sequence of tokens to satisfy your prompt based on the data it was trained on.
That's a really important point, especially for students using this for research or assignments.
Absolutely crucial. Grasping this distinction is key. The AI is excellent at sounding intelligent, articulate, even creative. But it's not a human brain. It's pattern matching and prediction on an unimaginable scale.
So it's not actually thinking like us, but it's incredibly good at sounding like it is by predicting that next best piece of text.
You got it.
Okay. And just to help everyone navigate this, because there are a lot of terms flying around, maybe we can quickly clarify some of the key ones we'll encounter.
Good idea. Let's define a few.
So AI, artificial intelligence, that's the big umbrella term, right?
Exactly. Computer systems mimicking or improving on human cognitive functions, reasoning, learning, problem solving, perception.
Okay. And machine learning, ML, that fits under AI.
Yep, ML is a subset of AI. It's where systems learn patterns directly from data without being explicitly programmed for every single rule. They improve through experience, essentially.
Like learning from examples.
Precisely. And then within ML, you often hear about deep learning.
Right.
That's a specific type of ML that uses these multi-layered neural networks systems inspired by the connections in the human brain to model really complex patterns and relationships in data. Deep learning is behind many recent breakthroughs in image recognition, natural language, etc.
Okay, so AI, ML, deep learning neural networks. Got hierarchy.
You got it. Now, shifting to the specific kind we're focused on today, generative AI.
That's the one that creates new stuff, right? Text, images, code.
Exactly. Creates novel content based on learned patterns. And the engine behind much of today's generative text AI is the LLM, the large language model, like GPT-4 or Google's Gemini, trained on massive text data specifically for language tasks.
Okay. And you mentioned foundation model earlier.
Right. A foundation model is a broad, usually very large model trained on diverse data that serves as a base or starting point for many different AI tasks. You can then fine-tune it for specific applications.
And the data they train on is called the corpus.
Yep. Corpus is just the term for a large collection or body of text or data used for training.
Okay. And when the AI gives us an answer, that's the model output.
Correct.
Triggered by our prompt.
The input you provide, yes.
And trying to get the best output by carefully crafting that prompt is prompt engineering.
That's becoming a skill in itself, absolutely.
Inside the prompt, the AI breaks it into tokens.
Those units of language, yes. Words, subwords, characters.
And the model's internal settings, those billions of knobs, are the parameters.
The values the model learned during training that shape its behavior.
And taking a big general model and tweaking it for a specific job, like medical summaries, is fine-tuning.
Exactly, specializing the model. So beyond just learning from massive data dumps, these AI systems also improve through feedback and specific training methods. There are a few key ways they learn. First, there's supervised learning. This is like teaching a student with a textbook and an answer key.
How so?
You show the AI lots of examples where the correct answer is already known. For instance, thousands of emails already labeled spam or not spam. The AI learns the patterns that distinguish between the two.
So it learns from labeled examples. What's that used for?
Things like spam filters, obviously. Also detecting financial fraud, identifying objects in images, even diagnosing diseases from medical scans where doctors have already provided the correct labels.
Got it.
And
What else?
Then there's self-supervised learning. This is clever. The AI learns by figuring out parts of the data on its own without explicit labels for every piece.
How does it do that?
Imagine giving the AI a sentence but blanking out one of the words. Its task is to predict the missing word based on the context of the surrounding words.
Ah, Like fill in the blanks on a massive scale.
Exactly. This method is absolutely fundamental to how tools like ChatGPT learn language so deeply. By predicting the next word or token in millions and millions of sentences from their training data, they learn grammar, context, and meaning implicitly.
That makes sense. Any others?
There's also semi-supervised learning, which is a hybrid. It uses a small amount of labeled data combined with a large amount of unlabeled data.
Why do that?
It's useful when getting labeled data is expensive or time-consuming. So if you only have a few hundred images clearly labeled cat, the AI can still learn effectively by comparing those labeled examples to thousands or millions of other unlabeled images, figuring out the common features.
Right, leveraging both types of data.
Precisely. Now, beyond just learning from examples, AI systems also get better through direct feedback and sometimes built-in rules.
Feedback, like telling it good job or bad job.
A really important method, especially for models like ChatGPT, is reinforcement learning with human feedback, or RLHF.
RLHF.
Okay. This is where humans directly rate or correct the AI's outputs. If the AI gives a bad answer, maybe it's unhelpful, nonsensical, biased, or unsafe, a human evaluator provides feedback.
Like a teacher correcting homework.
Exactly. The AI then uses this feedback signal to adjust its internal parameters, learning over time to produce responses that are more helpful, honest, harmless, and aligned with what the human raters prefer. This was crucial for making ChatGPT more conversational and less prone to generating problematic content.
So humans guide it towards better behavior.
Yes. And another approach, used by companies like Anthropic with their AI model Claude, is called constitutional AI.
Constitutional AI. Sounds official.
It sort of is. Here, the AI is trained to follow a set of predefined principles or rules, a constitution, that dictate desirable behavior. These rules might say things avoid generating harmful content or be truthful and helpful.
So it has built-in ethical guidelines.
Essentially, yes, a digital code of ethics. The AI learns to evaluate and revise its own responses based on these principles, aiming to keep its outputs safe, respectful, and aligned with human values right from the start, without needing constant human feedback for every single interaction. It's like giving the AI a built-in moral compass.
Fascinating. So different ways to train and refine them.
Absolutely. And understanding these methods helps explain why these systems get so good at what they do. It's not just magic, it's sophisticated training. And arguably, one of the biggest technical game changers that enabled the current wave of generative AI was something called the transformer architecture.
The transformer, I've heard that's the T in GPT.
Exactly. Generative Pre-trained Transformer. It was introduced in a landmark Google paper in 2017 called Attention is All You Need.
Catchy title. What was so revolutionary about it?
Before the transformer, most AI models processing language had to do it sequentially, word by word, one after the other. This created a bottleneck. It was hard for them to effectively grasp long-range dependencies and the overall context of a long piece of text.
Okay, so how did the transformer fix that?
Its key innovation was a mechanism called attention, which allowed the model to weigh the importance of different words in the input text simultaneously, regardless of their position. It could look at all the words in parallel.
Parallel processing for language.
Essentially, yes. It allowed the model to consider a vast web of relationships between words, concepts, writing style, the overall context all at once, much more effectively than previous methods.
And that made a big difference.
Monumental. It dramatically improved the model's ability to understand context and nuance. It also significantly sped up the training process because calculations could be parallelized much more efficiently. This meant models could be trained far quicker on much, much larger data sets.
Enabling the huge scale we see today.
Precisely. The result was models capable of generating far more sophisticated, coherent, and human-like text, understanding and producing complex relationships in language much more accurately. And its impact wasn't just limited to text. The transformer architecture has proven incredibly versatile and is now used in AI for audio, video, computer vision, bioinformatics. It really was a foundational leap.
Wow. So that transformer architecture really unlocked the complexity and fluency we're seeing now.
It was a key enabler, absolutely, a testament to the rapid evolution in this field.
Okay, so now that we have a better handle on, the mechanics behind generative AI, let's pivot. Let's talk about how it's actually showing up in the real world, how it's reshaping industries, our daily lives, especially focusing on knowledge work, productivity. This stuff is already impacting how you, as a learner, might approach your studies, your research, and definitely your future career.
Yeah, the impact on knowledge work is already quite profound and likely to accelerate.
So how is it changing the future of work?
Well, we're seeing it play this really interesting dual role. First, it's starting to automate a lot of structured, fairly routine tasks, things that take up mental energy, but maybe aren't the core value add.
Like what?
Imagine, for instance, an AI tool that sits in on your online meetings and automatically generates a detailed summary afterward, complete with action items assigned to people.
Okay, that'd be useful. Saves a lot of note-taking.
Exactly. It reduces your cognitive load, freeing up your attention for the actual discussion, for deeper thinking, for problem solving.
So automating the routine stuff, what's the second role?
The second role is tackling more unstructured tasks in ways that actually boost our cognitive capacity. It's not just taking work away, it's augmenting our abilities.
Recommending. How?
Think about brainstorming. Let's say you're working on a project, maybe for a marketing class, and you need some catchy slogans or new product names.
Yeah, that can be tough.
Well, you could prompt a generative AI. Give me 20 tagline options for a sustainable coffee brand. And boom, in seconds, you have 20 ideas. Maybe not all are winners, but it expands your creative range instantly, gets you unstuck, gives you starting points you might not have thought of.
So it's like a creative partner.
In many ways, yes. And perhaps most excitingly, especially for you as a student or anyone learning new things, is its power to improve the learning process itself.
How so?
AI tutors.
Personalized generative AI tutors are becoming a reality. Imagine an AI that can explain a really complex concept from physics or economics, but explain it in simple terms, using analogies tailored to your background knowledge at your pace.
Wow, that could be incredibly helpful.
It can help you grasp subjects faster, more effectively, whether it's for a specific class, a research project, or even learning a new skill on the job.
So summarizing, brainstorming, tutoring. What are some other common uses?
We're seeing generative AI shine in three main areas, broadly speaking: insight, creativity, and training or quality improvement.
Okay, break those down. Insight, synthesis, and summarization. AI can rapidly process huge amounts of text or data to extract key insights, conduct background research much faster, and create clear, concise summaries. Think about needing to analyze thousands of customer reviews for a business report to find the main complaints or praises.
Instead of reading them all manually.
Right. AI can do that synthesis in minutes. For creative thinking and brainstorming, as we mentioned, it's great for generating ideas, alternative approaches, names, solutions like those taglines. And for training and quality improvement, it can accelerate learning, review documents or code for errors, suggest improvements in clarity or style, almost like an instant proofreader or quality check.
It sounds like it really frees people up to focus on the higher level stuff.
That's the core idea, augmenting human capability, allowing professionals, students, everyone to focus on strategic thinking, critical analysis, complex problem solving, and genuine creativity by offloading some of the more routine or generative cognitive tasks.
And the big tech companies are jumping on this, right? Integrating it everywhere.
Absolutely. Microsoft is a prime example. They've heavily integrated generative AI across their ecosystem.
Like in Bing search.
Yep, they've added AI chat features directly into Bing search, trying to provide more direct answers and conversational search capabilities.
And inside Office apps, too.
Yes, that's Microsoft 365 Copilot. It's built on OpenAI's GPT models, combined with your own organizational data via Microsoft Graph. It acts as an assistant within Word, Excel, PowerPoint, Outlook, Teams.
What does it do there?
It can help you draft documents, summarize emails, create presentations, analyze data in spreadsheets, find information across your files, basically acting as an intelligent assistant embedded in your daily workflow tools. It's typically a paid add-on for businesses.
And they have something called Copilot Studio.
Right. That allows companies to customize Copilot or even build their own standalone AI assistants, embedding generative AI capabilities directly into their internal business systems, like ERP or CRM software. It's about making AI pervasive within the enterprise.
It's really getting integrated. What about coding?
Programming. Huge impact there, too. Generative AI is becoming an invaluable assistant for software developers.
Writing code for them.
It can definitely help write code snippets or even entire functions based on natural language descriptions, but it also does much more. Help document complex projects and even translate code between different programming languages.
Wow.
It builds very directly on this concept called pair programming, where two human developers work together at one computer, bouncing ideas off each other, catching errors.
So now one of the pair can be an AI.
Exactly. It significantly boosts developer productivity, helps with learning new languages or frameworks, and potentially allows developers to focus more on the high-level architectural design and less on routine boilerplate code.
Okay, so it's transforming knowledge work, coding.
Yeah.
What about some of those background AIs we might encounter? You mentioned spam filters earlier.
Right. Another common one you see all the time online is CAT-PCHA.
Ah, the squiggly letters or click all the traffic lights boxes.
Exactly. CAPTCHE stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart.
A mouthful.
It is. But its purpose is simple. Weed out automated bots. It gives you tasks that are generally easy for humans, but difficult for most computer programs. Typing distorted text, identifying objects and images. It's a basic test to verify you're a real person accessing a website or submitting a form.
Trying to stop spam bots and the like.
Precisely. And related, but kind of the opposite in function, is OCR, or optical character recognition.
OCR.
OCR technology reads and extracts text from images or scanned documents. It converts printed or sometimes even handwritten text into machine-readable digital text.
Oh, so like when you scan a document and can then search the text inside the PDF?
That's a perfect example. It's used for digitizing books, archiving receipts so you can search them, processing forms automatically. It's a foundational AI technology that lets us interact with the content of images.
And you said it's kind of the opposite of CAPTCHA.
Well, think about it. CAPTCH often work by presenting text in a distorted way, specifically to make it hard for OCR systems to read.
So one AI task is designed to defeat another AI task.
Clever. It highlights the ongoing cat and mouse game in some areas of AI development.
Okay, these examples really drive home that AI, and especially generative AI, isn't just for, writing essays or code. It's genuinely revolutionizing everything, often in really surprising and creative ways.
Absolutely. The breadth of application is astonishing.
Let's talk about some of those really cool, maybe unexpected real-world applications, like AI in high fashion.
Yes. The designer Iris van Herpen, who's known for her incredibly innovative, almost sculptural work.
Yeah, amazing stuff.
She actually collaborated with digital artists and AI tools to co-create a conceptual dress for one of her collections.
How did AI contribute to a dress?
Well, they trained an AI model on thousands of images from nature, things like jellyfish, feathers, the patterns of flowing water. The AI then generated unique, complex design patterns inspired by these natural forms.
So the AI came up with a pattern.
It generated patterns that the human designers then interpreted and refined. The result was this stunning fabric style with lightweight, layered, almost organic textures. It looked like a surreal blend of aquatic life and floral motifs, often realized using advanced techniques like 3D printing with specialized filaments or intricate laser cutting.
Wow. So AI as a creative muse for haute couture.
Exactly. It was celebrated as a real breakthrough in AI-assisted design, showing how AI can inspire human designers to push creative boundaries, not just automate tasks. It augmented their creativity.
That's incredible. What about something completely different, like perfume?
Also happening, there's a company called Every Human that has a service called Algorithmic Perfumery. They use AI to create completely bespoke, personalized scents.
Personalized perfume. How does that work?
Customers fill out a really detailed questionnaire. It asks about their personality traits, their preferences, memories, even their current mood or aspirations. The AI then analyzes all these responses, cross-referencing them with a massive database of scent profiles, chemical compositions, and known psychological associations with different smells. Based on that analysis, it generates unique fragrance formulas, blending natural and synthetic ingredients.
So the AI designs the perfume recipe.
Precisely. The outcome is usually a set of 3 distinct personalized perfumes crafted specifically to reflect that individual's unique profile and desires.
That's wild, taking personalization to a whole new level.
It really is. It shows how AI can move beyond mass market products and create truly individual, customized, even emotionally resonant experiences, transforming a very traditional, intuition-driven industry like perfumery.
Okay, fashion, fragrance. What about something really practical, like out on the water?
Yep. AI-enhanced boating. There's a New York startup called Viam that developed an AI system specifically for boats, and it's been put to the test in challenging conditions.
How so?
Captain Eric Collins used the system while navigating his boat through incredibly thick fog off Long Island near Jones Beach. Visibility was near zero.
That sounds terrifying. How did AI help?
The system integrated data in real time from all the boat's sensors, radar, sonar, GPS, plus environmental data like currents and weather patterns. The AI processed all this information simultaneously.
To what?
It could identify underwater structures like rocks or wrecks, pinpoint patterns indicating schools of fish, help avoid floating obstacles that radar might miss, and even optimize the boat's route for safety and, in his case, for better fishing.
So it gave him sight in the fog and helped him navigate safely and catch more fish.
Essentially, yes. It provided safe passage in really hazardous conditions and improved the efficiency of his work. It's a powerful example of how AI can bring enhanced precision, safety, and performance to traditional hands-on industries like fishing or commercial shipping, augmenting the captain's own experience and intuition with data-driven insights.
Fashion, perfume, fishing.
Yeah.
These examples really showcase the sheer versatility, don't they?
They absolutely do. What ties them together is this theme of AI augmenting human capability. Whether it's creativity, personalization, or safety and performance, it's about empowering people to achieve more, allowing them to focus on higher-level strategy, artistry, or critical decision-making by handling complex data analysis or generative tasks.
Yeah.
It's changing the nature of skill and expertise across the board.
Okay, so we've talked about the amazing potential, the cool applications, but we absolutely have to spend serious time on the other side of the coin. As powerful as AI is, it's equally profoundly risky when it's misused or even just developed carelessly without enough foresight.
Right, this is the crucial conversation part.
It really is. And these aren't, distant, maybe someday sci-fi challenges. We're talking about immediate pressing concerns that demand attention right now.
Like what? What are the big ones today? Well, key among them are issues like bias and discrimination. We've touched on this. AI systems, especially those trained on historical data, can easily learn and perpetuate societal biases. Think about hiring algorithms that inadvertently favor certain demographic groups over others because past hiring practices were biased.
Okay, bias is a big one.
Huge. Then there's the potential for outright abuse and misuse. We mentioned deepfakes, creating fake videos or audio for scams, propaganda, or personal attacks, or using generative AI to create targeted misinformation campaigns at scale, eroding trust in institutions and information sources.
Yeah, the misinformation potential feels enormous.
It is. And another major concern is power concentration. Developing cutting-edge AI, especially these massive foundation models, is incredibly expensive and resource-intensive.
Right, you mentioned the cost and computing power.
Which means that control over the most advanced AI capabilities tends to be concentrated in the hands of just a few dominant tech firms. This raises serious questions about equity, access, competition, and who gets to shape the future direction of this technology.
So bias, misuse, power concentration, these are happening now.
Absolutely. Responsible managers, policymakers, citizens, we all need to recognize and proactively address these risks. It's not optional anymore.
That's a really powerful way to frame it. It drives home that this isn't just theoretical. And knowing how to navigate that line between the incredible innovation AI offers and its very real potential for harm, that feels like it's becoming a core leadership skill, doesn't it?
I completely agree. For anyone in a position of influence, or frankly, for any informed citizen.
Tomorrow's best leaders, maybe today's best leaders, they'll be the ones constantly asking, how do we use this technology wisely? How do we use it ethically? Not just efficiently, but responsibly. It feels like a fundamental question for all of us, especially as you, the learner, start thinking about how you'll integrate these tools into your studies, your work, your life.
Well said. And digging a bit deeper into some specific risks, let's talk more about security and bias. From a security perspective, AI systems introduce new vulnerabilities. Well, they handle vast amounts of data, so there's always the risk of unintentional data leakage. Sensitive customer data, proprietary business information. If the AI system isn't properly secured, it could be exposed, leading to serious legal and financial harm.
Okay, data breaches through AI.
Then there's the risk of prompt injection. This is where malicious actors craft specific prompts designed to trick the AI into bypassing its safety controls and generating harmful, biased, or unintended outputs. It's like hacking the AI through its input.
Tricking the AI into doing bad things.
Exactly. And even more insidious is data poisoning. This is where attackers deliberately feed false, misleading, or biased data into the AI's training set.
To corrupt its learning.
Precisely.
Right.
If the AI learns from poisoned data, its outputs will be flawed, potentially leading to dangerous or discriminatory results down the line. The real-world impact of these security risks can range from leaked confidential information to manipulated financial advice to severely damaged company reputation.
Wow. And the bias issue, we need to unpack that more too.
Definitely. As we said, AI systems often reflect the biases present in their training data. It's almost unavoidable if you're not extremely careful. We saw the facial recognition example less accurate for people of color if trained mostly on white faces.
Right.
Similarly, some early self-driving car systems showed reduced detection rates for pedestrians with darker skin tones, and even for children, simply because the training data might have been skewed towards detecting white adult males. The safety implications there are terrifying.
So biased AI isn't just unfair, it can be dangerous.
Absolutely. It can lead to systemic discrimination in areas like hiring, loan applications, even criminal justice if predictive policing tools are biased. It poses significant safety risks, and it opens organizations up to substantial legal liabilities and reputational damage.
And that case you mentioned, Rona Wang, using AI on her LinkedIn photo,
Yeah.
that really hit home.
It was a stark illustration. She used a popular generative AI tool to enhance her profile picture, hoping for a more professional look.
And what happened?
The AI significantly lightened her skin tone, altered her eye shape, and essentially made her appear white, erasing her Asian features.
Whoa.
It immediately sparked outrage and highlighted profound concerns about the racial biases baked into these AI systems. What does the AI think professionalism looks like based on its training data? Apparently, in that case, it looked white. It's a vivid, disturbing example of how AI can unintentionally reinforce harmful societal biases and stereotypes just by mirroring the flawed data it learned from.
And you said this isn't just a one-off?
Sadly, no. There are numerous documented examples. Amazon famously had to scrap an AI recruiting tool because it learned from past hiring data that the company mostly hired men, so it started penalizing resumes that included the word women's, like women's chess club captain. Seriously. Google's hate speech detection tools were found to be more likely to flag comments written in African American vernacular English as offensive, revealing clear racial bias. A Bloomberg investigation using generative AI image tools found that prompts for high-paying jobs like CEO or lawyer predominantly generated images of light-skinned individuals, while prompts for lower-paying jobs like fast food worker or janitor generated images of mostly darker-skinned individuals.
That's deeply concerning.
It is. These aren't just hypothetical worries or edge cases. They show immediate, tangible risks baked into systems already in use, which underscores, again, why critical thinking and verifying AI outputs aren't optional. They are absolutely essential for responsible use. You cannot blindly trust the output.
Okay, so bias is huge. What about those hallucinations you mentioned earlier? Let's define that again.
Right, AI hallucinations. It's when the AI confidently generates content that is factually incorrect, misleading, or nonsensical, but presents it as if it were true. It sounds plausible, authoritative, but it's just made up.
And why does that matter so much? Why is it so critical?
Because if you believe the AI's output without checking it, without verification, it can lead to serious harm. Imagine making important decisions, financial, medical, legal, based on fabricated information. The consequences could be disastrous, both personally and professionally.
Have there been real examples of this causing problems?
Absolutely. The Washington Post reported on a case where ChatGPT falsely accused a real, named law professor of sexual harassment, citing a non-existent Washington Post article as its source. It completely fabricated the accusation and the evidence.
That's horrifying, ruining someone's reputation based on nothing.
Exactly. And on a slightly less reputation-destroying but still unsettling note, remember those AI-generated recipe suggestions? Things like recommending ant poison and glue sandwiches, or adding bleach to rice, or drinking methanol bliss.
Yeah, that's disturbing.
These aren't just funny glitches. They highlight the very real danger of unverified AI output, especially if it's giving instructions or advice. The AI doesn't know poison is bad. It just predicts tokens based on patterns. And sometimes those patterns lead to dangerously nonsensical outputs presented with utter confidence.
Okay, so hallucinations are a major pitfall.
A huge one, which leads directly into the broader issue of AI and deception, particularly the spread of misinformation.
Because the AI is so good at sounding convincing.
Precisely. Generative AI can produce fluent, grammatically perfect, convincing text. It can generate incredibly realistic-looking images and audio clips. This makes it easier than ever to create and spread falsehoods, propaganda, and scams quickly, cheaply, and at a massive scale.
And deepfakes are part of this.
Deepfakes are a prime example. AI-generated videos or audio that convincingly impersonate real people, politicians, celebrities, even ordinary citizens. They're already being used in sophisticated fraud attempts, political disinformation campaigns, and malicious personal attacks. It erodes our ability to trust what we see and hear.
And beyond deepfakes.
There's a growing problem of academic and creative fraud, students submitting AI-generated essays as their own work, or artists finding their styles copied by AI. It undermines trust, devalues original work, and poses serious challenges for education and creative industries. It's a huge concern for any learner trying to develop their own skills and integrity.
You mentioned a dangerous trifecta making this worse.
Yeah, it feels like we're facing this perfect storm. First, AI has vast access to digital content, text, images, video to learn from and imitate. Second, the tools to create this stuff are becoming incredibly easy to use, available to almost anyone, not just experts. And third, you have vibrant online communities actively sharing tips and tricks on how to bypass the safety filters built into these tools, sometimes with malicious intent.
Wow. Easy tools, tons of data, and people trying to break the rules.
It's a potent mix that makes combating AI-driven misinformation and harmful content a massive, urgent challenge for platforms, policymakers, and all of us as consumers of information.
And tangled up in all this is the question of copyright.
Right. Absolutely. A huge, thorny issue. These AI models, especially the big foundation models, train on colossal amounts of data scraped from the public internet.
Which includes copyrighted material.
Inevitably, yes. Billions of copyrighted images, articles, books, pieces of code. This raises critical legal and ethical questions.
Like what?
Well, first, is it fair use to train an AI on copyrighted material without permission or payment? Artists, writers, and publishers are already suing AI companies over this. Second, who is liable if the AI generates output that infringes on someone's copyright? If it spits out text that's clearly copied from a book or code that replicates proprietary software? Is it the AI user, the company that made the AI? Both.
Yeah, who's responsible?
And how can companies protect their own valuable proprietary data from being ingested into these models during training without their consent? Or ensure that AI-generated code used in their products doesn't inadvertently contain licensed or copyrighted snippets that could expose them to legal action?
These are huge unanswered questions.
They really are. The legal frameworks are scrambling to catch up with the technology. This creates significant uncertainty and risk for creators, AI developers, and anyone using these tools. It's a legal minefield right now.
So when we talk about AI's impact, it really goes way beyond just, will it take my job, or what cool new app can I use?
Oh, absolutely.
There are profound implications for the economy, for security, for the law, for ethics,
Yeah,
even for how decisions get made at a fundamental level.
precisely. And one of the most perplexing challenges underlying many of these issues is what's often called the black box problem in AI.
The black box, meaning we don't know what's going on inside.
Essentially, yes. Especially with complex deep learning models, they can make decisions or predictions based on patterns involving millions or billions of parameters as internal knobs. The resulting logic can be so complex and opaque that even the engineers who built the system often can't fully explain why the AI made a specific decision.
So it works, but we don't know how.
We might know it works most of the time, but understanding the internal reasoning is incredibly difficult. This lack of transparency, this opacity, makes it really hard to audit AI systems effectively, to explain their behavior or to justify their decisions, especially when things go wrong.
And that leads to problems.
It can lead to serious unintended consequences. Remember the flash crash in the stock market back in 2010? Automated, AI-driven, high-frequency trading algorithms contributed to a sudden, massive market plunge that wiped out about $1 trillion in value in minutes. The exact interaction of the algorithms was so complex, it was hard to pinpoint the precise cause immediately.
Wow, so the black box can have huge financial impacts.
And ethical ones, too. If an AI denies someone a loan or flags them as high risk, but we can't explain why, how do we ensure fairness? How do we appeal the decision? When harm occurs, whether it's financial loss or discrimination, this black box nature obscures responsibility. It makes accountability, legality, and fairness incredibly difficult to establish, even if the creators had good intentions.
That's a fundamental challenge. Okay, let's talk jobs then. That's on everyone's mind. What are the predictions?
Well, as you might expect, the predictions from industry leaders are varied, all over the map, really.
You can give me some examples.
Okay, so Dario Amodei, the CEO of Anthropic, the company behind Claude AI, made headlines predicting that AI could automate maybe 50% of entry-level white-collar tasks within the next 5 years. A pretty stark prediction.
50% in 5 years, wow.
Then you have Jensen Huang, the CEO of NVIDIA, the chip company powering much of this AI revolution. He believes basically every job will be affected. His message is stark. You either learn to use AI in your job, or you risk being left behind, potentially replaced by someone who does.
Use it or lose it, basically.
That seems to be his view. On the other hand, you have Demis Hassabis, head of Google DeepMind. He acknowledges that AI will likely replace some jobs, especially repetitive ones, but he also emphasizes that it will create valuable new jobs, particularly in STEM fields, science, technology, engineering, math. His focus is more on transformation and the need for new skills.
So some jobs lost, some jobs gained. Skills are key.
That's his take. And Michael Dell of Dell Technologies offers perhaps a more optimistic view. He predicted maybe only about a 10% net job loss directly due to AI in the near term, suggesting that its primary impact will be boosting productivity and driving innovation rather than mass unemployment.
So quite a range of opinions, from significant disruption to more of a productivity boost.
Exactly. What these diverse predictions really underscore, though, is a crucial point for anyone learning or working today. The future isn't necessarily about if AI changes jobs, but how quickly you can adapt to become an AI-augmented professional. Your ability to leverage these tools effectively in your field is likely to become as critical as the tools themselves.
It makes you wonder, that question, will the professor become an AI? Is that realistic?
Well, probably not tomorrow. The human element in teaching, mentorship, inspiration, adapting to individual student needs in real time is incredibly hard to replicate. But is it possible that universities could one day, say, combine video-captured lectures from their best professors on a topic, feed it all to an AI, and create some kind of ultra-engaging, hyper-informed, virtual super professor?
That sounds unsettlingly plausible.
It's certainly within the realm of future speculation, but more immediately, AI is already offering tangible benefits in education without replacing the professor.
Like what?
We mentioned AI tutors. Also, AI can enable much more effective flipped classrooms where students watch lecture content created or curated by AI outside of class, freeing up valuable in-class time for interactive exercises, discussions, and personalized help from the human teacher. And AI tools promise to make professors' office hours much more productive, allowing AI-empowered students to come with more focused questions, having already explored the basics with an AI assistant.
So it's more about augmenting the educational experience.
For now, that seems to be the primary focus, augmenting both the student's learning and the instructor's ability to provide targeted support.
Okay. Now, you mentioned earlier the sheer scale of this, the cost, the resources. Let's touch on that again.
Right, it's important context. Developing and running large-scale generative AI is incredibly costly and resource-intensive.
How costly?
Training GPT-3, just the training run, was estimated to cost around $4 million back in 2020. And the ongoing operational costs running the servers, the electricity can be enormous. One AI firm reportedly spent $40 million in a single month in early 2023 just on the computational costs of people using its model.
$40 million a month.
It highlights why this field is dominated by tech giants or heavily funded startups. Startups often need massive seed funding rounds, tens or hundreds of millions of dollars, just to get a competitive foundation model trained and launched.
And it's not just money, right? There's an environmental cost.
A significant one, yes. That massive computational demand translates into huge energy consumption and, often overlooked, water usage for cooling the data centers. For instance, training GPT-3 was estimated to have used as much electricity as about 1,000 average U.S. homes consume in a year.
Wow.
And it also consumed an estimated 700,000 liters of fresh water, mainly for cooling the servers. As these models get bigger and are used more widely, their environmental footprint is becoming a serious concern that needs more attention and mitigation strategies, like using renewable energy and more efficient hardware.
Okay, cost, environment.
Yeah.
What about the potential for actual destruction? You mentioned flash crashes, cyber warfare. Is that really happening?
Sadly, yes. When we talk about AI's destructive potential, it's not purely theoretical or future-gazing. It's already manifested in several domains.
Like finance.
We saw the finance examples, AI-driven flash crashes caused by interacting algorithms moving faster than human oversight can manage. Knight Capital Group losing $440 million in 45 minutes in 2012 due to a faulty trading algorithm deployment is a classic case study.
Okay. What about cyber warfare?
In cyber warfare, the risk is that powerful military-grade AI tools or exploits can fall into the wrong hands or be repurposed. A major example was in 2016 when cyber tools allegedly developed by the U.S. National Security Agency, NSA, were leaked online. These tools were then quickly incorporated into AI-assisted ransomware attacks like WannaCry and NotPetya in 2017.
WannaCry. I remember that. It hit hospitals, businesses.
Exactly. It crippled organizations globally, from the UK's National Health Service to banks and logistics companies. It showed how AI could amplify the speed and scale of cyber attacks using sophisticated, previously state-level tools.
And physical threats. You mentioned drones and robot dogs.
Yes, this is perhaps the most chilling area. We're seeing the emergence of AI-enabled autonomous weapons. A 2020 UN report documented an incident in the Libyan civil war where an AI-powered drone, likely Turkish-made, autonomously hunted down and attacked retreating soldiers without requiring direct human command for the final attack.
Wow. AI making the kill decision.
That's the implication, and it crosses a terrifying ethical line for many. More recently, we've seen demonstrations, particularly from China, of robot dogs armed with automatic rifles. These aren't just remote-controlled. They incorporate AI for navigation using LiDAR, potentially allowing for independent movement, targeting, and even operating in coordinated swarms with aerial drones.
Robot dogs with guns, working with drones.
They're reported to be fast, all-terrain, and capable of operating with minimal human oversight. This raises profound questions about the ethics and risks of autonomous weapons, of AI making life and death decisions on the battlefield. These are not speculative sci-fi scenarios anymore. The technology is being actively developed and, in some cases, deployed.
That is deeply sobering.
It is. It underscores the immense responsibility that comes with developing and deploying advanced AI.
Which brings us neatly to the challenges managers and regulators face. How do you manage this powerful, complex, potentially dangerous technology?
It's a massive challenge. For managers within organizations trying to adopt AI, there are several key hurdles. Data quality and bias is a big one. If your underlying data is incomplete, siloed across departments, or inherently biased, the AI built on it will be unreliable or unethical.
Yeah.
Garbage in, garbage out, amplified.
Right. Data hygiene is critical.
Absolutely. Then there's data security. You need robust measures to protect the AI models themselves, the data they're trained on, and the data they process. Breaches can expose incredibly sensitive information.
What else?
Insufficient data can be a problem, especially in fields like healthcare or HR, where privacy regulations limit data availability, or where you just don't have enough examples of rare events for the AI to learn effectively. The workforce shortage is another major issue. Finding and retaining talent with AI expertise is difficult and expensive, requiring significant investment in hiring or upskilling existing staff.
And just getting people on board.
Exactly. Change management is crucial but often underestimated. Successfully adopting AI isn't just about plugging in new software. It requires retraining staff, redesigning workflows, addressing employee concerns about job security. Resistance to change, if not managed well, can completely undermine an AI implementation.
Okay, those are internal challenges.
Yeah.
What about the broader legal, ethical, competitive landscape?
That's equally complex. We're starting to see legal limits being placed on AI use in certain contexts. New York City, for example, now requires mandatory audits of automated hiring algorithms to check for bias. We'll likely see more regulations like this.
Driven by concerns about misuse.
Often, yes. Past scandals involving data misuse, like Cambridge Analytica, directly led to stricter data privacy regulations like Europe's GDPR and California's CCPA. These laws now heavily influence how companies can collect and use data for AI.
What about workplace surveillance?
That's a tricky area. In the U.S., employer monitoring of employees is often legally permitted. AI makes the surveillance much easier, cheaper, and more pervasive, tracking keystrokes, analyzing communications, monitoring productivity. This raises significant ethical concerns about worker privacy and autonomy.
And competition. Does AI make it harder for smaller players?
It can definitely create strong first-mover advantages. Companies that adopted data-driven strategies early and amassed huge data sets, think Amazon in e-commerce and logistics, or Google in search, gain a powerful lasting edge. Their AI models, trained on more data, become better, creating a reinforcing cycle that makes it very hard for new entrants to compete effectively. AI can entrench market leaders.
So it's not just a technical challenge, it's legal, ethical, competitive.
It's all intertwined, and the ethical risks can pop up in unexpected places, like big data forensics. The Golden State Killer case is a fascinating example.
How is AI involved there? Or big data?
Investigators solved this decades-old cold case by uploading crime scene DNA to a public genealogy database, GEDmatch. They found distant relatives of the suspect, built out family trees using publicly available data, and eventually narrowed it down to Joseph D'Angelo. It was brilliant detective work enabled by big data and genealogical matching.
But ethical risks.
Huge privacy concerns. When you upload your DNA to one of these services, you're not just sharing your own data, you're potentially exposing your entire extended family, including relatives who never consented to participate. Consent gaps affect whole family trees.
I never thought of it that way. My
Yeah.
DNA implicates my relatives.
Exactly. And it highlights the potential for misuse. Could insurers or employers potentially use such databases to screen applicants based on genetic predispositions to certain diseases? Could it lead to a new form of genetic discrimination based on inherited traits you can't control? The technology solved a horrific crime, but opened a Pandora's box of ethical questions about genetic privacy and consent.
Wow, okay, that's a heavy example. Are there examples of companies using AI and data ethically for a positive user experience?
Absolutely. Spotify is often cited as a good case study here.
Spotify. How so?
Their acquisition of the Echo Nest back in 2014 was a pivotal moment. Echo Nest was an AI-driven music intelligence platform that analyzed music characteristics, listener preferences, and cultural trends.
And Spotify used that for recommendations.
They used it to power their entire personalization engine. This led directly to iconic features like Discover Weekly, their AI-curated playlist that generates billions of personalized recommendations every week, introducing users to new music they often love.
Yeah, Discover Weekly is amazing.
And things like Spotify Wrapped, their annual personalized summary of your listening habits, which became a viral social media phenomenon. Over 150 million users engaged with it in 2023. They also created Spotify for Artists, using data and AI insights to help musicians understand their audience and make smarter career decisions.
So they used AI to enhance the user experience and provide value.
Exactly. It shifted Spotify from just being a music streaming utility to becoming a data-driven discovery platform. They leveraged AI and user data, generally perceived ethically, to create deeply tailored experiences that users genuinely valued, building loyalty and engagement, all while helping artists connect with fans. It shows the positive potential when data and AI are used thoughtfully to enhance user value.
That's a good contrast. It really shows that responsible AI isn't just a technical puzzle, is it?
Not at all. It's fundamentally a leadership challenge, a legal challenge, a societal challenge. How we collectively navigate these complex issues, the biases, the risks, the ethical dilemmas, alongside the incredible potential will truly define our future relationship with artificial intelligence.
Which leads us to the final piece.
Yeah.
How do we actually build responsible AI? What steps can be taken?
Right. It requires a concerted effort on multiple fronts involving collaboration and robust oversight. We're seeing the beginnings of this through things like industry coalitions.
Like who?
Groups like the Partnership on AI. It brings together major tech companies, Amazon, Apple, Google, IBM, Microsoft, but also academic institutions and nonprofit organizations like Amnesty International and the ACLU. The goal is to develop and share best practices for ethical AI development.
So competitors working together on ethics.
In principle, yes. We're also seeing policy leadership initiatives like the Toronto Declaration, which advocates for AI systems that protect human rights and non-discrimination, endorsed by groups like Amnesty and Human Rights Watch. And standards bodies like the IEE are actively developing technical standards for the ethical design of AI and autonomous systems.
Why does this collaboration matter so much?
Because shared frameworks, standards, and principles help promote accountability and transparency. They encourage organizations to adopt best practices and provide a common baseline for evaluating AI systems globally. It's about creating a shared understanding of what responsible looks like.
Okay, so industry and policy efforts are important.
Yeah.
What about within organizations? What internal steps can companies take?
That's arguably where the rubber meets the road. Several crucial internal steps. First, hire diverse technical talent. Having teams with varied backgrounds and perspectives is essential for catching potential biases in design or data that a homogeneous team might miss.
Makes sense. Different eyes see different problems.
Exactly. Second, employ ethicists or provide substantial ethics training. Most software engineers, while brilliant technically, haven't had formal training in applied ethics. Having dedicated ethics expertise embedded in development teams is vital. Third, create a clear tech ethics code that's explicitly tied to the organization's core values. It provides a guiding compass.
Like a mission statement for AI ethics.
Precisely. And fourth, establish an AI systems review board or ethics council. This shouldn't just be engineers. It needs representation from legal, compliance, HR, maybe even frontline teams who understand the real-world impact, and external experts too. They provide crucial oversight and challenge assumptions.
It really sounds like building responsible AI isn't just a checkbox exercise.
Far from it. It requires proactive, ongoing effort, genuine collaboration across disciplines, and a real willingness within leadership to confront tough ethical questions and prioritize responsibility alongside innovation and profit.
And it doesn't stop once the AI is built, right? There's monitoring, auditing.
Absolutely critical. You need continuous vigilance. Organizations must enable robust audit trails, logging how AI systems make decisions, who access them, what data was used. This transparency is key for accountability and debugging when things go wrong.
So you can trace back what happened.
Yes. And encourage feedback mechanisms. Make it easy for users, employees, or the public to report flaws, biases, or harms they encounter with AI systems. This provides invaluable real-world data for improvement.
What about testing before launch?
Essential. Rigorous testing and red teaming are vital. Stress test the systems under various conditions to find weaknesses before they impact users. Red teams act like adversaries, deliberately trying to break the system or make it behave badly, exposing vulnerabilities that standard testing might miss.
Trying to anticipate misuse.
Exactly. However, despite knowing the best practices, there's a concerning gap in remediation. A PwC survey in 2023 found that only 43% of firms using AI had a clear process in place to actually override suspicious or harmful AI results,
Less than half have an override switch.
or at least a defined process for intervention. It highlights a significant gap between identifying risks and having concrete mechanisms to address them when they occur. There's a need for greater preparedness for when AI goes wrong.
And even with good intentions, setting up effective ethical governance seems really hard in practice.
It is proving incredibly challenging. We've seen high-profile struggles. Google's external AI ethics advisory board famously collapsed just days after its announcement in 2019 due to internal disagreements and external criticism. They also later disbanded an internal healthcare ethics review panel, reportedly over concerns about its lack of real authority and transparency.
So even the giants struggle with governance.
Yes, and the turmoil at OpenAI in late 2023, where CEO Sam Altman was suddenly fired by the nonprofit board, then quickly rehired after intense pressure from employees and investors, leading to the board itself being largely replaced, raised fundamental questions about the tension between the stated mission of ensuring safe AI development for humanity versus intense commercial pressures and profit motives. Who is really in control and whose interests are prioritized?
It shows governance structures are fragile and contested.
Highly contested. It underscores that ethical oversight isn't a one-time setup. It's a dynamic, ongoing, often messy process. The best practices often involve adopting established frameworks for IT governance and scaling, like ITIL or COBIT, and implementing gradual rollouts. Pilot new AI systems in limited controlled environments first. Learn, iterate, fix problems before deploying company-wide or to the public.
Learn before you leap.
Essentially, yes. These ongoing struggles with ethical governance really highlight that this is a continuous journey. There's no single static solution. It demands constant vigilance, adaptation, and a commitment to responsible practices from developers, leaders, policymakers, and users alike as AI continues its rapid evolution. Hashtag tag 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 outro.
Wow. Okay. We have covered a lot of ground today, a real deep dive indeed.
We certainly have.
We went from, the hidden AI running your spam filter and search results all the way to the cutting edge possibilities in things like high fashion and even perfume design. I mean, we really dug into the mechanics, the LLMs, the parameters, the transformers, how this stuff actually works under the hood.
Getting to the nitty-gritty.
But also, crucially, we spent significant time on the responsibility that comes with it. The risks of bias, hallucination, misuse, the ethical dilemmas, the governance challenges.
Absolutely vital context.
So hopefully, after all that, you, our listener, feel better armed. Armed of the knowledge to not just use AI, but to understand it more deeply, its definition, its workings, its applications, and especially its profound risks and the critical need for ethical consideration. You're better equipped now, hopefully, to engage with this transformative technology, not just as a passive consumer, but as an informed participant.
And perhaps this raises a final important question for you, the learner, to take away and reflect on. As AI continues its relentless evolution, creating both these incredible opportunities we discussed and also these significant complex challenges, how will you choose to leverage the knowledge you've gained today? How will you use it not just to adapt personally, but maybe even to contribute in your own way to shaping a more responsible, ethical, and innovative future with AI? What stands out to you from our conversation that you'll carry forward, applying it to your studies, your work, and your understanding of the rapidly changing world around you?
That's a great question to leave everyone with. Food for thought. Thank you so much for joining us on this deep dive today. Keep questioning, keep learning. Stay critical, stay curious, and we'll catch you on the next one.